Today we're going to be working on the Pythagorean theorem, lesson 9-5. Alright, there's 4 examples. Start with example number 1. I'll say, so first of all, we want to find the length of the hypotenuse of the right triangle. Before we can do that, you have to understand that there is a formula that you need to know. And this formula is c squared equals a squared plus b squared. And one of the most important things about the Pythagorean theorem is you find the 90-degree angle and go directly across from it, and that's always going to be your C, okay? This could be your A or your B, this could be your A or your B, but this directly across from that 90-degree angle is always your C. So that's a very key important reminder. So you have your formula, and then you substitute the numbers into your formula. So they decided that 21 is going to be the A, and 20 is going to be the B. So you have it substituted in now. You have c squared equals 21 squared plus 20 squared. When you square that on a computer, you get 441 and you get 400. Next step is to add those two numbers together. Now, here we are again. We have c squared equals 841. We're going to have to square root both sides of that equation. And remember, whenever we square a c or a variable with a square, it always comes out as the variable. And then when you do the square root of 841, it equals 29. So you just found that the length of the hypotenuse, which is the C, is 29 feet. That's another name for C. It's called the hypotenuse, and that's part of Pythagorean's theorem. Now it's your turn. Let's see how well you can do. So go ahead and write down this question. Draw out the triangle, 4 meters, 3 meters, and C meters. Remembering that your formula is, and I'll give you a little helpful hint here. And let's use yellow. Do we have yellow going on? No, we do. C squared equals a squared plus b squared. And remember, opposite of the 90-degree angle is your C, or also called your hypotenuse. Okay? I'll put HYP for short. That's your hypotenuse. It's always the opposite of the 90 degree. Now, you can let 4 be your A and 3 be your B, or vice versa. It doesn't matter as long as you're consistent and you stick with it. Okay? So go ahead and write down that question and see if you can find the answer. Okay, example number 2. Now we have to find the length of the leg of the right triangle. Guess what we have now? We have the C, we have the A, but we don't have the B. So we're going to set up the equation again, same thing, using Pythagorean's theorem. C squared equals a squared plus b squared. We're going to substitute what we know. We know the C is 11, and we know the A is 8. What we don't know is the B. Okay? This could get a little tricky now, so pay attention. 11 squared is 121, 8 squared is 64, plus b squared. We need to get rid of that 64, so we're going to have to subtract 64 from each side of the equation. Remember, that's what algebra is about. Just subtract or add. Do the same thing on both sides of the equation, equal sign. So when we subtract that, we get 57 equals b squared. Now, we're going to have to square root this because we want to know what b is. And since we square root this side, we're going to square root that side. Okay? And taking the square root of each side, we get 7.549834435 in our calculator. And so what we want to do is go to the nearest tenth, and that would be 7.5. That 4 keeps the 5 as a 5. Okay? And so again, on your calculators, it might be a little different. You might just have to type in 57 and hit the square root button. Different calculators work different ways, so you just have to get to know your calculator. Here's your turn. So go ahead and solve this one. This time we don't know the A, but we know the B and we know the C. Remember, the hypotenuse is always opposite of the 90-degree angle. You notice I keep saying that because it's a very important part of the equation, because as soon as if you call this B and this C, you'd be in a little bit of trouble. So remember, the hypotenuse, the C, is always opposite of the 90-degree angle. All right? So go ahead and write down your formula. C squared equals a squared plus b squared, and then solve. And pause and see if you can get the right answer. Okay, example number 3 now. You have a building that's 10 feet tall, and a ladder is positioned against the building so that the base of the ladder is 3 feet from the building. How long is the ladder? Now when you read that, you think, oh man, this is a tough question. What you need to do is you need to draw. Make a drawing, okay? Drawings always help. So if I can help you out with that, I'm going to make a little drawing here. It says a building is 10 feet tall. So this is going to be my building, and it's 10 feet tall. Okay? A ladder is positioned against the building. That means there's a ladder going from the top down to the bottom, right? And so that the base of the ladder is 3 feet from the building. So it might look like it's a lot more, but you just got to pretend, when I mark this down as 3 feet, that's what it is. Now, a building and the land or the cement or the grass or whatever it's on always makes a 90-degree angle. Okay, so we know that that's where the 90-degree angle is. So what are we missing here? We are missing the C. All right, so now we just set it up and solve it. So by taking it from words to a picture makes it so much easier. Okay, so that's what you want to do. This is the ladder, this is the building, this is the ground. The ladder at the bottom, it says, is 3 feet away from the building, and so you know that that's how you would set it up. And now you have your numbers. Choose this as A or B, it doesn't matter. This is A or B, it doesn't matter. I usually call this my B because it's on the bottom, and this my A, but that's up to you. Okay, so let's have a see, have a look, with, let the computer show us what we're doing. So they drew in a much nicer picture. Obviously, there's their building, and this is the ladder, and it's 3 feet away, and it's leaning up against the building. Okay. And so we're going to solve and find out what C is. Okay, so we use our formula. C squared equals 3 squared plus 10 squared. And we get 9 plus 100. And we get C squared equals 109. Now we have to square root both of those. And C is approximately 10.4 rounded to the nearest tenth. That's what you always want to do. Make sure you round it to the nearest tenth. When you punch that 109 square root in your calculator, you'll find round to the nearest tenth is 10.4. Okay? One thing about Pythagorean's theorem that you do need to know is this, that it works when you have only a right triangle. So there has to be a 90-degree angle in there, because that 90-degree angle, what's opposite of that 90-degree angle, is your hypotenuse. Okay, so now it's your turn. You don't need to write down all the answers here, but you do need to write down the question, make a drawing of it, and see which one you come up with it, what your answer is. Okay, so an 18-foot ladder is placed against a building, which is 14 feet tall. About how far is the base of the ladder from the building? The base of the ladder, which is at the bottom from the building, is what you're looking for now. So that's a little helpful hint. All right, go ahead and pause and see if you can find the answer to this question. All right, so the measurement of 3 sides of a triangle now are given, and you have to determine whether the triangle is a right triangle or not. It's like, how do I do that? Well, what you use is Pythagorean's theorem. And one thing that you're going to learn is, in Pythagorean's theorem, the C is always the largest side, or the largest segment, okay? So that's always going to be your C. That doesn't matter if that's your A or if that's your B, A or B, it doesn't matter. But your C is always going to be the longest one when you put it into Pythagorean's theorem. So you'll notice we put 78 squared here where C is, right? And then 48 squared plus 60 squared. Now, to figure out if it's a right triangle, when we get this, you notice we have a question mark right now. We want to know, does this equal this? And that's what we're going to try and figure out. All right? Don't add 60 plus 48 and get 108 and say, no, it doesn't add up, it doesn't work. What you need to do is square root 78, square root 48, square root 60, and then add the two numbers. And when you do that, and add the two numbers, you'll see that they don't equal each other. Therefore, since they do not equal each other, it's not a right triangle. So this triangle is not a right triangle. Okay, so the answer to that one is no. Looking at the next one, we now have 24, 70, and 74. Again, we choose 74 as our C, because it's the longest segment, and then 24 and 70, A and B. It works. So when we set that up, we use Pythagorean's theorem, substitute in, we get 5,476. We add those two together, they equal each other. So these particular measurements makes a right triangle. So the answer to this question is, yes, this is a right triangle. Okay? So now your turn, they're going to give you two different ones here, and you can go ahead and figure out if they are right triangles or not. Remembering that the largest one is going to be your C, so for A here, 84 is going to be your C, and then you can figure out for B what your C would be. Always the largest, obviously. So go ahead and pause right now and see if you can find the answers to these. And that's the end of the lesson.